So good afternoon to all. I welcome all of you to the last day of our faculty development program on artificial intelligence, machine learning, and data science for engineering application, jointly conducted by E&ICT Academy, Department of CSE, NIT Warangal, and Department of EC, SJB Institute of Technology, Bengaluru. So yesterday we started the fundamental aspects of recommender system. We have seen the simple architecture of a recommendation system in which we have four components. We have a user, we have database, we have a recommender system, and we have a set of items. Then we have discussed about three important questions related to database, recommendation system, and set of items. So the first question arises that which information do we use to make recommendation, which is related to the database, and we have seen different type of information. So in order to design a recommendation system, you need some of the information. You don't need all these information. All informations are not important to develop a recommendation system. Then with respect to the recommender system, we have addressed one question, that is how to implement a recommender system. Then with respect to set of items, we have seen one question, that how to evaluate a recommender system. So after this, we have addressed these three questions. We have seen different type of feedback, that is implicit feedback and explicit feedback. We have seen also two different type of recommender system. One is collaborative filtering based recommendation system, which is similarity between two different items, two different users. Another part is content based recommendation system, where we consider similarity between two different items. And we have also seen an example with 5 different smartphones and 2 different features. One is battery, another is display, and seen the difference between collaborative filtering system and content-based system. So basically, we have seen a user feature matrix, an item feature matrix, and a user item rating matrix. Then we have discussed about the cold start problem, which happens in the collaborative filtering system. So this problem can be categorized with respect to new user or new item. Then in order to evaluate the recommendation system, we see some of the performance matrices. That is, accuracy is one of the performance metrics, diversity is another performance matrix, trust, serendipity, mean absolute error, root mean square error, decision, recall, F1 score. These are the different factors we have seen. Then we have discussed about in-depth architecture of recommender system, in which we have 2 different filters and 1 matching process. So filter approach is used to extract the valuable items, or I can say subset of the items from a database, and we match with the feature of the user and generate a score. So once we generate a particular score, the items which are having high score, that will be selected by another filter. So that is in-depth architecture of a recommendation system. So that we have seen. Then we further categorize the recommendation system into 2 parts. One is memory-based system, another is model-based system. So both collaborative filtering system and content-based system is categorized into memory-based system and model-based system. So basically, if you see, it is a 4 different type of recommendation system. So memory-based system uses similarity matrices, whereas model-based system create a model. So instead of taking the database, we are taking the model database. We convert the database into model database through a learner. So basically, when we convert the database into model database, so the model database is having key features of different user, different items, or if you talk about the content-based system, we consider set of forms. So once you generate these number of features, these features will help you to generate a particular score. The score will help you to generate the recommendations. So that we have discussed. And also we have seen the confusion matrix. In confusion matrix, we have seen true positive, false positive, or also called type 1 error, then true negative and false negative. False negative is called as type 2 error. So basically we divide a data set into the data set into training data set and testing data set. So based upon that, we see whether whatever the item suggested by a recommendation system, so whether the user adopt that particular item or not. Okay, so for that we have taken the confusion matrices. So these are the topics that we have discussed in the yesterday's lecture. So in the today's lecture, we'll see two different activity, as I mentioned earlier also. So first we'll go for activity 1, which is focusing on how to design a recommendation system in the first phase. And in the second phase, it focuses on how to evaluate the recommendation system. And in the second activity, I'll show you with respect to the very famous k-nearest neighbor algorithm, how to generate the recommendations. In that angle also, we'll see two different types, that is oriented to the user and oriented to the item. After that, we'll see some of the similarity functions and aggregate functions, different variants of aggregate function, and we compare one performance with another performance. So in the first activity, you are given with 11 different users and 15 different items. And basically it is a user item rating matrix. So you are given with the ratings given by different users. So this matrix is not a filled matrix. It is not completely filled. So it is partially filled because all the users have not purchased all the items. So for example, if you see user U1 purchased 5 items, that is I1, I2, I3, I5 and I8 out of 15 items. Similarly, U2 purchased I can say 9 items out of 15 items, or some of the items that purchased by a particular user, but the user has not rated that item. So this particular user item matrix is given to you. What you have to do, suppose I'll ask you, U1 has purchased 5 items out of 15 items. So what are the other items this particular user may be interested for, right? So 5 items it is purchased, so rest 10 items are there. So out of 10 items, if I ask you to suggest 2 items, that I'm going to suggest to user U1. So the user 1 may get a notification that these are the 2 items based upon your past history or based upon your previous likes, right? So what are the 2 items? How to select 2 items out of the rest 10 items? So that for that we want to design a recommendation system. So now here you can see, if I ask you with respect to this activity 1, whether it is a collaborative filtering system or it is a content-based system. So you will say it is a collaborative filtering system. Why? In the collaborative filtering system, you are given with the user item rating matrix. But when you go for content-based system, you are given with the user feature matrix and this item feature matrix. But user item rating matrix is not given in the content-based system. So I told you 4 different types of recommendation system. So if you see these 4 types of recommendation system, if it is collaborative filtering type, as it is given the user item rating matrix, so obviously 2 part out of 4, 2 is eliminated because it is not a content-based system. Now the next question arises that if it is a collaborative filtering system, whether it is a memory-based system or it is a model-based system. So that we need to understand. So that I'll tell you in the subsequent slide. So our database is having 11 different users and 15 different items, or a matrix with 11 cross 15 dimension, right? So where 11 users have purchased some of the items out of 15 items. Now, if you see this architecture where database is converted into model database. So there are two types of collaborative filtering system. One is the model-based system, another is memory-based system. So in memory-based system, we consider the database and we apply the filtering approach. But when we go for model-based system, in that case, the database is converted to a model database and filtering is applied to the model database. It is not applied to the database directly, right? So here you can see database is converted into model database through a learner and filtering is applied to the model database, right? It is not applied to the database directly. But in the memory-based system, the filtering is directly applied to the database. Yeah, if anybody is having any doubt, you can ask. Okay. So it is a model-based system. Under the collaborative filtering system, it is a model-based system. So now, out of these four possibilities, I have only one, right? So given an input, you can decide whether it is a collaborative filtering system or a content-based system. Once you identify the collaborative filtering system and content-based system, you can further classify that whether it is a memory-based system or it is a model-based system, right? So anyhow, for this particular activity, it is a collaborative filtering system and it is a model-based system. So what you can do, you can create a Excel sheet. In that Excel sheet, you can type this 11 different users and 15 different items. So I'll share a Excel sheet with you. In fact, I have that Excel sheet. I can show you directly also. So you can see here, I have a book one. Let me show you this book one. So you can create a Excel sheet. Okay, this is my Excel sheet in which I have taken 11 different users and 15 different items, and whatever value is given in that activity. So it is given 3. 3 indicates that user 1 purchased item number I1 and rated 3 out of 5. Whereas this 5 indicates that U1 purchased item number 3 and rated 5 out of 5. And this blank indicates that user 1 has not purchased that particular item. So all of you can type this particular thing, whatever I am highlighting here, into an Excel sheet, right? So there is no need of explicit programming in order to implement a recommender system. So you can do it by the help of Microsoft Excel also, right? So now let me go back to the slide. Now what we will do, what is the difference between a database and a model database? So in regression also we have seen, we create a particular model. So based upon the past data, we create a model. So when you feed the current data, it will predict, right? So we don't need the past data whenever we deal with the current data, rather than we take the model. So here you can see our model database is giving a particular value to each and every item. Okay, every item, you can say I1 to I15, it is given with one particular value. I'll tell you how to generate this particular value later. So now the database is converted into model database. Okay, database is having this whole matrix of 11 different users and 15 different items. But your model database is having only 15 different items and it is just one dimensional. It is not a two-dimensional one. Like here you can see it is a two-dimensional. But when you go for model database, it is a one-dimensional. So how to convert the database into model database? I told you there is a learner. So what the learner is doing for this particular activity, the learner is actually determining the average value. For example, if you go to item I1 is purchased by different users. For example, I1 is purchased by U1, U2, and U6, and U11 also. So there are 4 users who purchased I1. So I can write here I1 I1. So U1 has purchased and rated 3 out of 5. U2 has purchased that one, which is 4 out of 5. U6 also purchased, it is 2 out of 5. U11 also purchased, it is 1 out of 5. So if I find the average value, average is 3 plus 4 plus 2 plus 1 divided by 4, because 4 users have purchased. So if you calculate this value, how much you are going to get? It is 10 divided by 4. So you will get 2.50. So this is can be considered as your uh, this is you are taking from a database, but this value you are getting from a model database. So I am showing you a very simple one by taking the average. Similarly, if I ask you to calculate for I3, so I3 is purchased by, if you see I3 is purchased by U1, U2, U3, and U7. U1, U2, U3, U7. So if I calculate its average, that is 5 plus 4 plus 4 plus 2 divided by 4. So you will get how much? 5 plus 4, 9 plus 4, 13 plus 2, 15. So 15 divided by 4. So 15 divided by 4 means you will get the value as 3.75. So your model database is having 3.75, where your database is having 5442. So like this, if you carry out for determining by finding the average value for each and every item, you will get an average value. For every item, you will get an average value, right? Once you determine average value of each and every item, so that is available in the model database. So whenever you want to predict something, you will look into the model database, but you are not going to further check the database. Okay, you will only focus on the model database. You will focus on the model database. You will not no more see this particular matrix. That's why it is called as model based system. And it's because this matrix is directly given to you, user item matrix. So I can say it is a collaborative filtering system. Okay. So this is the way you can design a collaborative collaborative filtering system, and or you can say you can design a model based system. So once you determine this average value, what you will do? So those items are not purchased by the user. On that location, you are going to put the average value. For example, if you see this slide, so the average value for item I1, we have calculated as 2.5. You see in the previous slide, the average value we have calculated as 2.5. So those users have not purchased item item I1. So for example, in this case, U3 has not purchased I1, U4 has not purchased, U5, and U7, U8, U9, and U10. On those locations, you will put the value as 2.5. Okay, I am putting 2.5. Those locations where the value is not there. Okay. I'm guessing this is the rating that I'm going to get for this user based upon the average measure. Okay. So now, if you see, for example, if you go for item number 4, I4, what is the average value? For I4, if you calculate the average value, you can calculate using this matrix also. For I4, it is 5 plus 4 plus 1 plus 1 divided by 4. So it is 11 divided by 4. 11 divided by 4 means you can say it is 5.5 divided by 2. Okay, 5.5 divided by 2. So you will get 2.75. So these locations you will put 2.75. Okay, this is the location where you will put the value as 2.75. So once you put like this, the matrix look like this one. What I can say, if a value is available in the top table, on the top table, so in the bottom table that value will not be there, because these are the actual ratings and these values are considered as the predicted rating. And here the predicted rating is determined. Okay, predicted rating is determined based upon the average value. Okay, So these two matrices are, you can say, it is reverse to each other, in the sense that if a value is available in the first matrix, it is not available in the second matrix, right? So once you fill this value, this value looks like this one. So now, if you concentrate on a particular user, for example, I want to focus on user U1. Okay, user U1. So for user U1, you got, these are the predicted ratings. So user has purchased 5 items, and you got how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you got 10 predicted value, and 5 items are purchased by that particular user. So now, if you look into these values, which value is having a very higher value? That is more important. Okay, which value is close to 5? Because 5 is the best rating, right? So which value is having highest rating? Which item is having highest rating? So in this case, you can see I6 is predicted as 5 out of 5. I10 is also predicted as 5 out of 5. I13 is also predicted 5 out of 5. So these are the 3 items, like I6, I10 and I13 are the 3 items that is suggested to user U1. Similarly, if you go for U6 case, you can see this value is 5, this value is 5, and this value is 4.67, which is close to 5. So it also, you have to also decide how many items you are going to suggest. For example, here I'm suggesting 3 items. Here also I'm suggesting 3 items. So that's why 5, 5, 4.67. Okay, so now if you see, in this case, I'm going to suggest item number 5, item number 13, and item number 14 to the user number 6. Similarly, if you talk about U11 case, you are getting 5 here. Okay, you are also getting 5 here. You are also getting 4.67 here, which is close to 5. So you are going to suggest user 11 is given the item for suggestion, that is I5, I13, I14, which is same as U6. Like that, you can select any user. Let us take another user, that is U8. U8 case, you can see here you are getting 5, here you are getting 5, here also you are getting 5. So I5, I6 and I10, these are the 3 items that you are going to suggest to user number 8. Okay, so in this way you can design a recommendation system and you can predict a recommendation system. But the most challenge is that what is the guarantee that the developed recommendation system is performing better than the existing recommendation system? So in order to do this one, first you have to evaluate the recommendation system. If you evaluate the developed recommendation system, so whatever performance measure values you will get, if the performance measure values of your developed algorithm is better compared to performance measure values of others, right, or your existing model, then definitely you can say your proposed model is better. Otherwise, you can say there is no improvement. Okay, so in order to do this one, we'll go for phase 2. So phase 2 objective is to evaluate the recommendation system. So generally, we evaluate the recommendation system using mean absolute error and RMSE, root mean square error, where our objective is to minimize MAE and minimize the RMSE. And also our objective is to maximize the value of precision, recall, and F1 score. Okay, but sometimes what happens, a particular model, okay, may perform better, provide better precision, and your competing algorithm will give better recall. So your algorithm is good in precision but not in recall, whereas another algorithm which is not good in precision but in recall. So in order to compensate this, in order to balance this, or in order to make a trade-off between these two, we have F1 score, which takes precision and recall, and we are calculating 2 into precision into recall divided by precision plus recall. So if F1 score value of a particular model is better in comparison to other models, so definitely that model is better. So that's why when precision recall conflict arises, we can go for F1 score. Similarly, we have another matrix that is called as FMI. So FMI also makes a trade-off between the precision and recall. Okay. Now what we'll do is this data is given to you and we have to perform the process of training and testing. So we'll remove some of the elements from this particular matrix. So how to remove some elements from the matrix? So you have to do randomly only. So you can see here, I am randomly removing these elements which I have colored here, right? So that values I am going to remove from the matrix and I call the new matrix as test matrix. And remaining values which are not colored, that will be as it is. We call that as a training matrix. Or that, as I mentioned earlier also, data set is split into training set, another is testing set. So these removed values will be put in the testing set and remaining value will put in the training set. So what we will do, training set and testing set, once you put training set and testing set, okay, once we divide it into training set and testing set. So first we will model the, we will train our model and we will predict the value for the elements that we have removed in the elements that are present in the testing set. So that will help us to check that whether the predicted rating is equal to the actual rating or there is any difference that we can easily identify. So you can see once I remove these elements, the matrix look like this one, which I mentioned here is training data set. So once you have removed some of the elements from the original matrix, again the average value is going to be changed. For example, if you remember that for the given data, if you know what is the average rating of item I1, we got average rating of I1 is 2.50. But here you can see I have removed one of the rating, that is U1, user U1 who rated for item I1, that we have removed for and we kept in the test data set, right? So the average value is going to be now changed. So for example, for I1, if I calculate the average value, so now it is 3 plus 4 plus 2 divided by 3. So you will get 9 by 3, your value will get is 3. So earlier it is 2.50 because there are 4 ratings, but now we have only 3 ratings. That's why the value is now increased to 3, right? Similarly, if I calculate for item number 2, we have 4 users, so it is 4 plus 5 plus 1 plus 1 divided by 4. So how much you will get? It is 9 plus 2, 11 divided by 4. So 11 divided by 4, you will get the value is 2.75. But if you recheck the previous one, I2 also I have removed to 3 items. You can see 4 I have removed, 5 and 1. So earlier I think it is 4 plus 4 plus 5 plus 1 plus 5 plus 1 plus 1. So I think there are 7 items we have, right? 1, 2, 3, 4, 5, 6, 7. So 4 plus 4, 8, 8 plus 5, 13, plus 1, 14, plus 5, 19, plus 1, 20, plus 1, 21. So 21 divided by 7. So average rating is earlier 3. So now you have removed 3 ratings. So the value you are getting, average rating, you are getting 2.75. So you will get different values because if some of the data you have removed, then you will get a different value. Now, once you have determined the average value on the training data, so you will make prediction. So once you make a prediction, I'll check how whatever the values you are getting, whatever the rating values you are getting, how far it is from our actual value. Okay. So for example, you can see, now you can see these are the elements that are present in the testing data set, right? So which I have sent it here so that you can easily identify. So for example, this particular one, okay, what value you are going to predict? You have to go to the average value. So average value is calculated here, it is 3. Right? This value is 3. So I am going to predict this value is 3. Similarly, for I2, you have removed 3 elements. For I2, you calculated the average is 2.75. Average you have calculated is 2.75. 2.75, right? So I am going to suggest 2.75 for these three values: 2.75, 2.75, and 2.75. Okay, so once you predict these values, okay, then I have to show that what is the actual value. Once you know the actual value and predicted value, then only you are going to calculate the error, whether it is a mean absolute error or a root mean square error, right? So these are the elements which are the actual value. You can see in the first matrix, these values are the actual rating. These are the actual rating, and these are the predicted rating. Okay, one is actual rating, another is the predicted rating. So now, if you calculate mean absolute error, so mean absolute error, if I go column wise, so the actual rating is 1. What is the predicted rating? Predicted rating is 3. So 1 minus 3 modulus is your error. Similarly, if I take for this one 4 minus 2.75 plus 5 minus 2.75 plus 1 minus 2.75 plus 4 minus 3.67 plus, okay, this is also covered. Then 5 minus 5. For this particular element, error is 0. And this 5 minus 5 is over. This is also 5 minus 5. 5 minus 5 plus 1 minus 4.8 plus 5 minus 4. 5 minus 4 plus, then if I take this 5 minus 4 again, 5 minus 4 plus 5 minus 4.20, 5 minus 4.20 plus 5 minus 5. Okay, this divided by total number of elements is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So can anybody calculate and tell me what is the value? Okay, if you solve this one, you will get the mean absolute error. And if the value is close to 0, then your actual rating is more or less equal to the predicted rating. So if you calculate and all are modulus, so you will get positive value. 1 minus 3 is same as 3 minus 1. So I think you will here you will get 2 plus here you will get 1.25 plus here you will get 2.25 plus here you will get 1.75 plus here you will get 0.33 plus 0 plus 0 plus 3.8 plus 1 plus 1 plus 5 minus 4.0 is 0.8 plus 0 divided by 12. Okay, so if you calculate this, 2 plus, you can use your mobile phone calculator and calculate it, plus 2 plus 1.25 plus 2.25 plus 1.75 plus 0.33 plus 3.8 plus 1 plus 1 only, 2 times 1 plus 0.8. Okay, so you will get the value as 14.18, and if you divide by 12, you will get the value is 1.18. Okay, in this way you can calculate the mean absolute error. Similarly, you can calculate the root mean square error. So root mean square error case, what you will do, instead of finding the difference between the actual rating and predicted rating, you will find actual rating minus predicted rating, its square. Okay, so for example, in this case, if you see, instead of taking this 1 minus 3, what I'll write? 1 minus 3 whole square. For this one, I'll write 4 minus 2.75 whole square. Like that, I'll continue up to this. That is 5 minus 5 whole square divided by 12. So if you calculate this one, and it finds its root over, you will get the value is 1.60. So many research articles also suggested that RMSE is a better measure compared to the MAE. But most of the article shows both MAE and RMSE into their simulation or experimental result. Right. So in this way, you can calculate MAE, RMSE. For example, you are also calculating MAE and RMSE value for your existing algorithm. And let's say you are getting, in existing case, you are getting more MAE, RMSE value than your developed recommendation system. Then you can claim your recommendation system is better than the existing system. So apart from MAE and RMSE, you can take another three measures as I mentioned earlier. One is precision, another is recall, another is F1 score. So in order to calculate the precision, so what you will do, first you have to put a particular threshold. For example, here I am putting a threshold as 4. So those ratings are greater than equal to 4, that only I am going to consider. For example, if you go for, this is your actual rating matrix, actual rating. This is my predicted rating, right? So what I'll do, I will find how many predicted ratings are greater than 4. How many predicted ratings are greater than 4? So total is 12. Total ratings that we have removed and formed a data set, right? We have formed a data set which is called as a testing data set. So out of 12 values, how many values are greater than equal to 4? So you can see here, in this case, it is not greater than 4. It is not greater than equal to 4. It is not greater than equal to 4. This is not greater than equal to 4. This is not greater than equal to 4. But these values are greater than equal to 4. Okay. So how many values we have? We have 5 plus 2, 7 values. So our denominator shows that particular one. Okay. So precision in the denominator part, we are getting 7. What precision indicates? Precision is calculated based on number of true positive cases divided by number of true positive cases plus number of false positive cases. So number of true positive cases and false positive cases, you got 7. Now you have to determine how many true positive cases are there. So you will go to the corresponding position of the actual matrix, actual rating matrix. If you go to their corresponding position, these are the corresponding positions, right? So in these corresponding positions, you have to find how many of these actual ratings are greater than equal to 4. So in this case, you can see 6 out of 7 values are greater than equal to 4. So number of true positive cases is 6. So 6 divided by 7. 6 divided by 7, because this is not satisfying, right? So precision is calculated as 6 divided by 7, that is 0.86. Okay, if you calculate this one, you will get the value as 0.86. Similarly, again you have to calculate precision of your existing approach. You have to consider number of true positive cases divided by number of true positive cases and false positive cases. Okay, so if your precision value is better, okay, then definitely your approach is better. Okay, subjected to, will check the recall part also. Okay, now this is my actual matrix, right? Actual rating matrix, and this is my predicted rating matrix. Actual rating matrix, another is predicted rating matrix. So now, previously you are checking how many predicted ratings are greater than equal to 4. So now you have to check that how many actual ratings are greater than equal to 4. Because when you calculate the recall, the formula is number of true positive cases. So both cases numerator is same, but denominator case we are taking number of true positive cases and number of false negative cases. Okay, So for example, in this case, if you go for actual rating, so we have 12 observations in our testing data set. Out of 12 observations, how many ratings are greater than equal to 4? So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are there, but these are not greater than equal to 4. So I am eliminating it. So in denominator, as it is number of true positive cases plus number of false negative cases, we are getting 9. But if you go to their corresponding positions, these are their corresponding position, right? Which for which the actual rating is greater than equal to 4. So I'm like highlighting that. Okay. So these are the I can say 9 ratings. Okay, this is also 9 ratings, which are for which the actual rating is greater than equal to 4. But we have to also look how many of the predicted ratings are also greater than equal to 4. So if you see this one, only 1, 2, 3, 4, 5, 6, because these are not satisfying. 1, 2, 3, 4, 5, 6. Only 6 are qualifying. So number of true positive cases is considered as 6. The number of true positive false negative cases we calculated 9. So recall, you are getting here a 0.67. So in the previous slide, you got precision. Precision you got is 6 by 7 is 0.86. 6 by 7 is equal to 0.86. But recall, you are getting number of true positive cases divided by number of true positive cases plus false negative cases. Okay. And there is a trade-off between these two. Sometimes in your approach, recall is better, but precision is not better. Another case, you can say recall is better, precision is not better. So we determine the F score or F1 score. It is calculated as 2 into precision into recall divided by precision plus recall. So in this case, if you calculate 2 into, what is our precision here? Our precision is 0.86 multiplied by recall, that is 0.67. Divided by precision is 0.86 plus recall is 0.67. So if you calculate, in how much you are getting? 2 into 0.86 multiplied by 0.67. So numerator you are getting 1.1524. Denominator you are getting 0.86 plus 0.67. So it is 1.53. So 1.1524 divided by 1.53. So I am getting the value as 0.7532. Okay, that is my F1 score. So I will also find F1 score of the existing algorithm, right? Or if you are comparing with more algorithm, you have to determine the F1 score of all the algorithms. So out of these algorithms, we found that F1 score is better. If the proposed F1 score is better compared to existing approach, so definitely we are going to accept that particular one. Okay, so in this way, actually, the first activity where we created a newly developed recommendation system and we evaluate that recommendation system. So very quickly, in just a minute. Okay, so if you go to Microsoft Excel, so you can see here I have taken the data, whatever is given input, where we have 11 different users and 15 different items. So in order to calculate the average value, so in Excel we have a formula is equal to average. You have to mention where to where. For example, I am mentioning B3 to B13. You can see B3 to B13 is now highlighted. So it is calculating B3 to B13. So if the value is not there, it is excluding that. So 3 plus 4 plus 2 plus 1. So it is 7 plus 2, 9 plus 1 is 10 divided by 4. So I am getting the average value is 2.50. Okay. So it is the first phase. So once you determine this value, now I told you if the value is already there in this particular matrix, so there is no need to predict. Only those places there is a rating is not available. That value only we have to predict. For example, I want to predict this particular value, U1 and I4. So U1 and I4, the value should be 2.75. So for Excel, if you want to implement, so in Excel you can mention if E3 is nothing but the corresponding value of this particular matrix. If it is nil or if it is greater than 0, it is blank here. Okay, so it is equal to 0 or it is equal to nil. So if it is equal to greater than equal to 0, means for example I1 case, it is greater than equal to 0, right? 3 is greater than equal to 0, then we will put a blank. So double quote and there is a blank space here. So it is going to put a blank here. But if that value is not available, like I4 case, the value is not available and E3 is greater than equal to 0 is not satisfied, in that case you will put $14. $14 means you can see 2.75 we are going to put. Okay, and the meaning of dollar is constant in Excel, right? So it may change. For example, if I go for E column to F column, that is going to be changed, but the row number is going to be fixed. Okay, it is 14, so it is fixed. Okay, now in this way you can generate this particular matrix. Okay, now what I'll do, I have to remove some of the elements from the matrix. So this X indicates that I am removing that element and making a testing matrix, and remaining values I'll keep in my training matrix. So this is my training matrix. So now again I have to calculate the average. So for example, I am calculating average here. The value is 3 plus 4 plus 2 divided by 3, because this value is removed and put in the testing data. Right now, for this particular value, I am going to predict what is the rating. Right, so actual rating is we have removed. Okay, but predicted rating is now 3. Right, but what is the actual rating? Actual rating is 1. So 3 and 1. If you calculate error, so it is 3 minus 1 modulus or 1 minus 3 modulus. Similarly, you have to do for all other cases. For example, in the case I am saying, I have removed this particular rating. So 4 plus 5 plus 1 plus 1. 4 plus 5 is 9, plus 1 is 10, plus 11 divided by 4. So you will get the value is 2.75. Okay, so in order to predict these values, you have to put the value 2.75. So you can see here we put the value is 2.75. But what is the actual rating? The actual rating is 4, 5 and 1. So I have to subtract 4 minus 2.75 modulus, 5 minus 2.75 modulus, and 1 minus 2.75 modulus. Okay, that will give us, but if you calculate that, that will give us the error value. Okay, so which I told you in terms of ME and RMS. So in this way, using a Microsoft Excel file, we can implement a recommendation system. We don't need any modern or traditional programming language if we are not compatible. Right? If you are compatible in Python, R, or C, C++, you can also implement it. But using Microsoft Excel also we can do. But you should know some basic formula like average and if clause, how to write if clause. And also you have to see what is the use of dollar in Microsoft Excel. So that will help you to calculate, to calculate the average value and predicted value and compare with the actual value. Okay, so this is the first activity, and I'll show you another activity, that is second activity using a nearest neighbor algorithm. But before that, we'll see the basic related to k nearest neighbor algorithm. And once we understand the KNN algorithm, then we'll go for the second activity, where we'll split the activity into two parts. One is oriented to the user, another is oriented to the item. So for example, you can see, if you look into KNN algorithm, it is in KNN algorithm falls under the collaborative filtering based recommendation system. So we have four type of recommendation system: collaborative filtering, memory based, and another is model based. Similarly, content based recommendation system also we have memory based and model based. So under collaborative filtering based recommendation system and under the category of memory based system, we have KNN algorithm. So KNN algorithm focus on the memory rather than the model. So we don't have a model. In the first activity, we focused on the model, but this activity will focus on the memory based. So which will complete our idea about the collaborative filtering system. Yes, KNN algorithm can be viewed in two ways in recommendation system. It can be viewed from the user perspective, or it can be viewed in the item perspective, which we call as oriented to the users, and another is oriented to items. Okay, now if you go for oriented to the users or oriented to the items, so in this case, what happened? For example, we have, let's say, k number of users, right? In a particular system, suppose we have n number of users, and out of n, I have to select k, and the relationship between the k and n is that k is much less than the n. N is nothing but the total number of users. For example, in our example, we have taken the total number of users. Total number of users is 15. Okay, total number of users is 15. But out of 15, we took, suppose k value is 3. Okay, so we need to find 3 neighbors out of 15 different neighbors, right? So whatever the users having very close interest is that particular user, that you have to select. For example, U1 is close to let's say 3 different users like U2, U3, U4. So you are going to consider U2, U3, U4 only. Okay, out of all other users, right? So k users with the same test as the given user, that you have to determine. Once you determine, for example, here you can see, when you take a k different user, one user may rate 2 out of 5, another user may rate 1 out of 5, another user has not rated, another user has 2 out of 5. So what you will do, you, by considering their rating value, you have to consolidate their rating value. Okay, so step 1 is to select k neighbors and make sure that the neighbors which you are selecting, that users has having same interest or taste as the user you are considering, right? And once it is done, then in the second step, you have to aggregate the ratings of the k neighbors. I have to aggregate. Suppose I am taking k value is 3, and all the 3 users are giving the rating 5 out of 5. So the aggregated rating is also considered 5 out of 5. Okay. So for example, here you can see I am considering user perspective. So oriented to the user means your decision is based upon the set of users. You have to select another user, and for example, I am comparing the interest of U1 with another user, let's say U2. When I compare the interest of U1 and U2, I find the similarity is 0.8. So if you have mutual interest, then you will get a higher value. If you don't have any mutual interest, you will get a low value. So for example, I am getting similarity is 0.8. I checked with another user, so I got similarity 0.9. So in order to generate, in order to find k neighbors, you have to try with all n neighbors. After finding n neighbors only, you have to select the best k, because I told you k is less than n. That is the relationship. Now I'm checking with another user. I got the similarity value is 0.3. Similarly, I can, if I compare with n different users, I will get n different similarity value. But k is a small value, right, in comparison to n. K is a very small value in comparison to n. So I have to select k different user out of n based upon the similarity value. For example, if I ask you to select, let's say 2k is equal to 2 in this case, and I have given the value for three different users. One is 0.8, another is 0.9, and another is 0.3. So you have to select k users with the highest similarity. So obviously the highest similarity is 0.9 and second highest similarity is 0.8. Let's say third highest is 0.3. So 0.8 and 0.9 is going to come, and 0.3 is going to be eliminated. So in this way, you are going to select a k number of users out of n different users. Now, yeah, so once you get this rating, so you got similarity, right? Based on the similarity, you selected two different users. Okay, so based upon the similarity, you selected. Based upon the similarity, you have selected two different users. But what rating they have given, that you need to check. For example, let's say first user has rated 4 out of 5, second user rated 5 out of 5. So what the aggregate function is going to take? Aggregate of the function is to take 4 plus 5 divided by 2. So 4 plus 5 divided by 2, it is, you will get 4.5. So your aggregate function is taking mean of the ratings given by two different users. So 4 plus 5 divided by 2, it is 4.5. So we can expect that when that particular user is going to purchase a particular item based upon the recommendation of its k neighbors, which is equal to 2 here. So we expect a rating 4.5 from that particular user. Okay. So in this way, the KNN algorithm makes a decision. Now here I'll tell you there is a measure that is called as mean square difference. In order to determine the mean square difference, you have to take the vector of U1. The vector of U1 is nothing but what are the items purchased by user U1. Similarly, you take the vector of U3, the items purchased by user 3. But I am interested to know what are the common items purchased by U1 and U3. That will give us me the mean square difference, or we call it as MSD. So MSD is taking the common interest of the two different users. For example, here you can see U1 has purchased I1, I2, I3, I5, and U3 has purchased I2, I3, I4, and I5, and I8 also, right? But if you see the common interest of U1 and U3, so it is coming I2, I3, and I5. I2, I3, and I5. So if you calculate the mean square difference of these two users, that is U1 and U3, it is nothing but 5 minus 5 whole square plus 3 minus 4 whole square plus 2 minus 2 whole square divided by 3. So 3 items are common between these two users. So it is 5 minus 5 whole square plus 3 minus 4 whole square plus 2 minus 2 whole square divided by 3. So you will get the value as 0.33. That is the similarity function. So not necessary that you will take mean square difference is the similarity function. So there are different types of similarity function is there in the literature. But if you consider MSD is your similarity function, you will get the value as 0.33. Now, based upon this concept, we are going to conduct a second activity. Okay, if you have any questions till now, you can ask. Okay, so we'll conduct the second activity. In the second activity, you can see the question is that calculate the score of item I4 for user U1. So U1 to I4. Suppose U1 is interested to purchase item I4. So if you are using KNN algorithm where K is equal to 2, and if it is oriented to the user, what is the rating the user E1 is going to give for item I4. So you have to predict that one, right? So you have to predict this one based upon two neighbors, right? So let us see. So you can see I have highlighted it in yellow color. What yellow color indicates? U1 is interested in I4, and you have to predict the rating that U1 will give for item I4 if he purchase that item and rated the item, right? So for this, what we will do, we'll go for two different approaches as I mentioned. But here the approach says that you have to go to oriented to the users. And once oriented to the users is over, then I'll tell you how to do it with oriented to the items. Okay. So if you go for oriented to the user, so suppose I am taking here user U1 and item I4. So I have to find the similarity between different users. So I have to find the similarity between U1 to U2, U1 to U3, and U1 to U4. Like that, I will calculate U1 to U11. So once I calculate the similarity value for all these users, so for similarity function, I told you about mean square difference. So that is called as MSD. So mean square difference I have to calculate with respect to each pair of user, where the first one is U1 and another user may be anyone, U2, U3. I have to calculate for all n users. So once I calculate the similarity value, I have to select the two similarity value, two best similarity value, and I'll consider that those users are having very less similarity value. Okay, best two similarity value as the neighbor of user U1. So for example, here you can see if I calculate the similarity between U1 and U2, so I have to find that what are the items common in U1 and U2. So you can see I1 is common in U1 and U2, and I2 is also common in U1 and U2. Just a minute. Yeah, these two items are common. I1 is common, purchased by U1 and U2. I2 is also purchased by U1 and U2. I3 also purchased by U1 U2, and I5 is also purchased by U1 and U2. That means there are 4 items that are purchased by both users, U1 and U2, right? So if you calculate the MSD, because here you can see some of the items are purchased by U1, but it is not purchased by U2, or some of the item purchased by U2, but it is not purchased by U1. So I am not considering those items. So if I calculate here, so it is nothing but, if I see, I will take these 4 elements and calculate it. It is nothing but 3 minus 4 whole square plus 4 minus 4 whole square plus 5 minus 4 whole square plus 5 minus 5 whole square divided by 4. So if you calculate this one, you will get the value is 0.5. So the similarity between U1 and U2 is 0.50. So I don't know whether this is the best similarity or not. So I need to calculate the similarity value of U1 with all other users. So once I determine this, then only I can decide that which user is close of U1. So like that, if you proceed with U1 with U3, U1 with U4, up to U1 with U11, you will get some similarity value. But the interesting part is that when you compare U1 with U8, so U1 purchased these items, right? I1, I2, I3, I5, and I8. Okay. But U8 has not purchased I1, I2, I3, I5, and I8. Similarly, U8 has purchased I11, I12, I13, I14, I15. But these items are not purchased by U1, right? That's why the mean square difference between U1 and U8 is not determined. It is not possible to determine if both users don't have any common interest. So it is put as a dot, and I highlighted in yellow. So this is also an important problem with respect to the KNN algorithm. So KNN algorithm is failed to determine the similarity value of a particular item. So in line with this also, our research group also done a good work related to the KNN algorithm, and whatever problem I'm showing here, that MSD of U1 and U8 is not determined. So if you follow one of my article, which is published in the year of 2020, in which I have addressed this problem, and where we can say that if there is no common interest between two different user, how to determine the similarity value. Okay, so once you have determined these two, you can see the lowest similarity value. Okay, your lowest similarity is better. Sorry, lowest MSD value is better. So the lowest MSD value you are getting for user U2 and U3, because U2 case you are getting 0.5, U3 case you are getting 0.75. Okay, so I can consider the neighbor of U1 is U2 and U3. So now once you know who are the neighbors of user U1, okay, that is U2 and U3, then you can find the values. For example, I am interested in the rating value of U1 and I4, right? The question asks you to calculate U1 and I4. So if I want to calculate this value, I will look into the value of user U2 and U3, because U2 and U3 are close to I4. So in this case, if you see, it is 5 plus 4 divided by 2. So you will get 9 by 2. Okay, so that is 4.5. So if U2 and U3 are the neighbors, then we can predict the value is 4.5. Okay, but still our problem is not going to be solved. For example, you can see here, suppose instead of U1 and I4, suppose I'll ask you to calculate U1 and I6. U1 and I6. So if you calculate U1, I6, you will depend on the user U2 and U3. But U2, U3 has not purchased that particular item. So as U2, U3 has not purchased that item, so you cannot determine the rating value for user U1 and I6. So this is the main problem, right, which I have addressed in one of my article. So some of these values, not only I6, you can see I10, I13, I14, it is not possible to determine. And some of the cases, like if you see the case of I9, okay, I9, okay, not I9, I'll show you here, I think. Okay, some of the items which are purchased by, for example, I am determining for U1 and U2, U3 is the neighbor, right? I am determining a rating value for U1. So for example, I assume that U2 only purchased that item and rated 1 out of 5, but U3 has not purchased that item. So as per the KNN algorithm, although you are taking two neighbors, right? Although you are taking two neighbors, but you will consider only one neighbor. So the rating is given is 1 out of 5 by U1. So which is not true. Sometimes a single rating may be a biased rating. Okay, it is a biased rating because two you are taking k value is equal to 2, but actually the k value is equal to 1 here. So that type of issues also you are going to face. Okay, so you have to avoid that one. Now, similarly, if you go for oriented to the items, okay, oriented to the item case, in this case, instead of calculating the similarity between two users, you have to find the similarity between two different items. For example, you can see I am asking the same one, like calculate the score of I4 for user U1, so this yellow element with the KNN algorithm, but here you take oriented to the item. It is not user perspective, it is item perspective. So you have to find the similarity between two different items rather than two different users. For example, if I take the similarity between I4 and I1, so I have to find the users who purchased I4 as well as I1. Then only I can find the similarity. So in this case, if you see, like U2 has purchased both I4. Yes, they have purchased. U2 has purchased I1 and I4 is both purchased by U2. Similarly, I can say, is there any other common element? No, I don't think so. Okay, so if you calculate the MSD, it is nothing but 5 minus 4 whole square by 1. So you will get the value as 1. Okay, but if you calculate MSD of I4, I2, so what are the common elements between I4 and I2? So you can see U2 has purchased, U3 has purchased both, U5 has purchased both. both items, and U10 is purchased. So it is 4 minus 5 whole square plus 5 minus 4 whole square plus 5 minus 1 whole square plus 1 minus 1 whole square divided by 4. So if you calculate it, you will get the value is 4.5. Okay. So in this way, you can calculate the mean square difference of a particular item against other items. So once you determine, again also you can see some of the item case you are not getting. For example, if I calculate, ask you to calculate MSD of I4 and I13. I4 and I13. So you don't know. You will not able to calculate because there is no user that are common for purchasing I4 and I13 jointly, right? None of the user has taken this combination. So you have to exclude it. Similarly, if you go for I14, okay, if you go for I14, MSD of I4 and I14 is also not determined because there is no common user who purchased both items, I4 and I13. So the problem which we have seen in oriented to the user, similarly we have also faced the problem with respect to oriented to the item. And some of the cases also, for example, you can see if I ask you who are the neighbor of I4, and based upon the similarity value, you can say the neighbor is I3 and I5. But some of the item case, what you are seeing here, those items you want to guess for I4, but it is not purchased by both I3 and I5. Or some of the cases, the rating is the item is purchased by I3, but the item is not purchased by I5. I5 has not purchased this one. So even if you calculate the aggregate rating, 2 is going to come. So which may be a biased rating. So you have to avoid this particular case. Okay. So although KNN algorithm depends upon K neighbor, but you have to ensure that both neighbor has rated that item. Otherwise, that is of no use. Okay, this is another part where you can conduct the second activity. Similarly, as I mentioned, you can implement the same thing using Microsoft Excel also. So as an activity, so as you are aware that how to write code in Microsoft Excel, and I showed you with respect to the activity 1. Similarly, you can also do it with the activity 2. So create an Excel file, and using this KNN algorithm, you can predict the rating. Now, the last part which I am going to tell you, okay, anyhow, this you know that once you determine the similarity value, if the values are 5, then this rating is also 5. Okay, the last part which I want to mention here, that is nothing but the similarity function. So under similarity function, we have two important parts. One is called as similarity measures. So in the previous till now, whatever we discussed about the MSD, that is mean square difference, right? And once you determine the MSD, once you determine this MSD, then you are calculating based upon the minimum MSD. You are selecting a particular user using KNN algorithm. But instead of MSD, you can also go for the cosine similarity measure or Pearson correlation similarity measure. These are also very popular similarity measure that is used in the literature. Similarly, if you want to go for aggregate function, till now we use the aggregate function as average. We use the aggregate function as average. We have used weighted average or difference from mean. But these are also can be used as aggregate function. And not necessarily these are the complete list of similarity measures and aggregate functions. So there are so many type of functions also there, or similarity measures are there. So you have to carefully find a proper similarity measure for your designing or evaluating the recommendation system. And this is not with respect to oriented to the user, it is also with respect to oriented to the item. So quickly, I'll tell you about the similarity measures, then aggregate function, so that you have an overall idea that instead of MSD, if you apply cosine, how it impacts. Right? Sometimes you can see if you have designed a recommendation system, if you are using MSD, your result is not good. But when you use cosine and Pearson correlation, your result is good. Or instead of average, if you are taking weighted average, it is working. right? So that's why we use a variety of similarity measure and aggregation function to evaluate our recommendation system. Okay, so we'll go for the similarity function. Similarity function, we already told you MSD. So let me go directly to here. Yeah, again, I'm showing you an example how MSD is calculated. So if you want to calculate MSD of two different users, first you have to find what are the common items purchased by two different users. For example, in this case, you can see U1 purchased I1, I2, I3, and I5, and U3 purchased I2, I3, I4, I5, and I8. But the common items between U1 and U2 is I2, I3, and I5. Right? These are the common items between these two. So if you find the MSD is 5 minus 5 whole square. Here you can see 5 minus 5 whole square plus 3 minus 4 whole square plus 2 minus 2 whole square divided by 3. So 5 minus 5 is 0, 3 minus 4 is 1 square, plus 2 minus 2 is again 0. So 1 divided by 3 means you are going to get the similarity function value is 0.33. Yes, you are getting 0.33. So this I already told you, so there is no need to again tell this thing. Okay, now we'll go for the another similarity that is called as cosine similarity. Okay, so what is the problem with MSD? Why we are going for this type of similarity, that you need to understand. Right. For example, here you can see I am taking two users. Let's say U1 and U3. Right. So U1 is a boy and U3 is a girl. So the user U1 seems to be more severe when rating than other user, especially U3. And MSD informs that these users do not set the same test. For example, there is a when we are rating a particular item, we can say one user is lenient, whereas another user is very strict, right? So their rating is different, right? For example, you can if you say that 4 out of 5 means it is a very nice product, but somebody can feel that 2 out of 5 means it is also a very good product, right? So rating values of the different users are different. And some users are either giving 4 or 5, whereas some users are giving 1 to 5. Some users are giving 1 to 4, right? Based upon their assessment. So these assessments are not captured using MSD. So you can say indeed both users seems to set the same test, but that is not happen in the case of MSD. So in order to avoid this, what we are going to do? So we calculate here the square of ratings and sum of the square of rating and its root over. For example, U3 case, the common item between U and U3 is I2, I3, and I5. So for user U3, I am calculating 5 square plus 5 square plus 2 square and its root over. Okay, so you are getting the value is 7.35. Okay, so now if you see how to normalize this value, so once you get 7.35, you have to normalize this value. Normalize this value means you will take all the elements and divide it by 7.35. So if you do this one for user 3, it is 5 divided by 7.35, 5 divided by again 7.35, again 2 divided by 7.35. The values are 0.68, 0.68, and 0.27. Now similarly, you have to calculate for U1 also. So U1 case also you will take 4 square plus 4 square plus 1 square and its root over. So 4 square is 16. This is also 16 and plus 1 and its root over. So you will get root 33. Okay. So if you find root 33, how much you are getting? Can anybody tell? Root 33. So root 33, you will get the value is 5.75.7445625. So I'm taking up to 2 decimal place. Okay. So I'm getting 5.74. So once I get 5.74, how to normalize these values? So it is 4 divided by 5.74. So I'm getting the value is 0.70. Again 4 divided by 5.70, I'm getting 0.70. And 1 divided by 5.74, I'm getting the value is 0.17. So now I have the values, normalized value of U1 and U3. And this normalization is performed based upon the square of each rating, sum of the square of the rating, and its root over. And once you determine these values, you can apply MSD. So how to apply MSD, you know, right? 0.70 minus 0.68 whole square plus 0.70 plus minus 0.68 whole square plus 0.17 minus 0.27 whole square. So you will get the similarity value is 0.04. Okay. So if you apply MSD there, but if you apply the cosine similarity, the formula for cosine similarity is given here. So cosine similarity is calculated as 4 into 5, okay, plus again 4 into 5 for item 3, then 1 into 2, okay, in the numerator part, and denominator part you have to take 4 square plus 4 square plus 1 square and its root over, and which is multiplied with U3, that is 5 square plus 5 square plus 2 square and its root over. So that will give you the cosine similarity. So in this case, you are going to get the cosine similarity 0.52. Okay, cosine similarity we are getting is 0.52. So now this is about MSD and correlation. So MSD case, what you are doing? I told you earlier. Suppose these are the values that is given to you. Okay, let's say these values. So you will do for this one, 0.70 minus 0.68 whole square plus 0.70 0.68 whole square plus 0.17 minus 0.27 whole square divided by 3. That will give you 0.04. And cosine similarity case, we are multiplying the corresponding rating of a particular item, and denominator part we are taking square of all the ratings of different users and its root over, right? So now we'll see how the Pearson correlation works and what is the benefit of going for Pearson correlation from cosine similarity. So for example, here you can see, again I am taking two users. The first user seems to consider lower rating value for the indifference rating than the other user. Okay, there is an indifference rating. But the cosine similarity measure informs that these users do not completely set the same test. Okay, so that is the reason why we are going for Pearson correlation. So here both users seems to set the same test, right? So in order to find the Pearson relation, what you are going to do, you have to calculate the average rating. For example, once you determine what are the common items between two different users, then you have to calculate the average rating. Like for example, here you can see average rating I am calculating for U3, that is 3 plus 4 plus 2 divided by 3. So you are getting, I think 9 divided by 3, that you will get 3. Similarly, if you calculate for U1, it is 2 plus 3 plus 1 divided by 3. So how much you will get? 2 plus 3 is 5 plus 1, 6 divided by 3. So you will get the value is 2. Okay. Now what you will get, once you determine the average value, you have to subtract the average value from each and every rating. For example, for U3 case, it is 3 minus 3, 4 minus 3, and 2 minus 3. So you will get the value is 0, 1, minus 1. Similarly, we can determine for U1, right? If you calculate for U1, it is 2 minus 2, 3 minus 2, and 1 minus 2. So you will get the value is 0, 1, minus 1. So again, you got this value. So if you go for cosine similarity, okay, if you go for cosine similarity, you know cosine similarity is nothing but 0 into 0 plus 1 into 1 plus minus 1 into minus 1. Again, 1 you will get, right? Minus 1 both are now positive, right? Negative is positive. So divided by, I will calculate 0 square plus 1 square plus minus 1 whole square root over, and 0 square plus 1 square minus 1 square root over. Okay. So if you calculate this one, you will get similarity function is 1. Okay. So in order to go for cosine similarity, if you calculate the cosine similarity here using this particular formula, so you will get cosine similarity value is equal to, cosine similarity case, you are also getting the value is equal to 1. Right? Using this particular formula, you can calculate this one. Okay, so this is we have seen for oriented to the user. Similarly, we can do for oriented to the items as well. Right? But what I'll tell you now, I'll tell you about the coverage of similarity functions. For example, we have also experienced that if I take U1, U4, so there is no common item between U1 and U4. You can see here, right? U1 purchased I1, I2, I3, and I5, and U4 purchased I6 to I10. So there are not common rating between these users. Okay, so if you go for MSD, go for cosine similarity, or you go for Pearson correlation, none of the method will work, right? So we can say the previous definitions are not well defined, and the similarity is considered as completely low, right? So now what we are going to do in this case, I am calculating cosine similarity of, let's say, two users. One is U and B. So that is determined as AB divided by root over of A square and root over of B square. That we have already seen. The value is 1. So here only one item has rated by both users. Right. Previously you have seen there is no common item, but now I am showing you a case where there is exactly one common item. Like in this case, you can see U1, U4 case, only I2 is common. Rest things are as it is. So as only one item has been rated by both users, the cosine similarity is considered as 1. And cosine similarity is redefined to completely low for these cases. Another case you can see, suppose you go for Pearson correlation. Okay. So there also you assume that there is only one item is rated. Okay. So there also Pearson correlation is failed to do this, right? So for example, Pearson relations are not well defined and similarity is redefined to be completely low for these cases. Okay. And you have to ensure that the denominator is if equal to 0, then it is undefined, right? Okay, so here you can see if you go for similarity function with the two items, like here you can see U1, U4 case, I am considering two items. One is item 2 and the other is item 5. So only two items have been rated by both users. So you will, if you calculate the Pearson correlation using this formula, okay, between U and B, you will find either the Pearson correlation is +1 or you will get the Pearson correlation is -1. So the similarity is redefined to be completely low for these cases. So for example, if you abbreviate it, it is nothing but A minus A plus B whole square, A minus A plus B divided by 2 multiplied by C minus C plus D divided by 2, where A and B are the two items purchased by U1 and C, D are the two items purchased by U4, and these are common items. Okay, A, B, C, D are the what? They are nothing but the ratings. So if you calculate the similarity function using Pearson correlation, it is A minus A plus B divided by 2, C minus C plus D divided by 2, plus B minus D minus A divided by 2, D minus C plus D divided by 2, and in denominator part, it is root over of A minus A plus B divided by 2 and its whole square, plus B minus A by 2 its whole square, and root over of multiplied by the root over of C minus C plus D whole square, C plus 2D divided by 2 whole square, plus B minus C plus D divided by 2 and its whole square. So that will give you the Pearson correlation. So you are going to calculate, if you mathematically solve it, right, you simplify it, you will get the value as either +1 or you will get the value as -1. There is no other way. Either you will get a value of +1 or you will get a value of -1. So if you solve, you know that simplification of these mathematical terms, so I'm not showing you in detail. So if you calculate, you will get +1 or -1. So these are the issues which we face with MSD and you can say Pearson correlation or cosine. So some measures are not good for when there is no common item. Some measures are not working for one rating, and some measures are not coming for two ratings. So what we have to do, we have to think that if we design a good similarity function which can help us to solve the problem of these different type of measures. So for this also, our research group have also proposed one type of function. I'll share the paper with you, these two papers. One is related to the KNN, another is related to the similarity function. So once you go through this one, you will come to know that what is the new thing in that. Okay, and then what makes our proposed approach is better compared to Pearson correlation, cosine, and MSD. Now the last part of this one, the second part I can say, that is called as aggregate function. So I told you aggregate function is used to consolidate it, right? So like average, somebody is rated 4, somebody is rated 5, so it is 4 plus 5 by 2. So I can say 4.5. So I can go for average measure, I can go for weighted average measure, or I can go for difference from mean. Okay, so for example, if I go for average measure, okay, average measure was already seen, so I'll show you again here. Like U3 rated 4 out of 5, U10 rated 5 out of 5. So how you are aggregating? You are aggregating 4 plus 5 divided by 2. So we got value is 4.5. But when you go for, let's say, I5, if you want to aggregate, so the value is 2 plus 2 plus 1 plus 4. So it is 4, 2 plus 2 is 4 plus 1, 5 plus 4, that is 9. 9 divided by 4. So how much you will get? You will get the value 9 by 4, that is 4.5 by 2. Okay, you will get 2 point something, right? So in this way, you can calculate the aggregate function, right, which we have seen throughout the presentations. Now we'll go for another two measures that is more important. The first measure which I want to discuss, that is called as weighted average. So weighted average means whenever you are taking k different neighbors, all the neighbors are not treated equally. Okay, so if you take also 5 friends, you can put a specific weight to your friends. Okay, so for example, if you trust someone more, then you can put a higher weight than the person you are not that much trustworthy, right? So that is the reason why we are calculating the weighted average. So for example, in the previous calculation, if you look for item I4 is purchased by U3 and U10, but it is not purchased by U1 and U7, right? So the value is 4 plus 5 divided by 2. So that we got is 4.5. Okay, in that case you are getting 4.5. But in this case, you have to put a weight value. For example, I decided the weight value of a particular user is 0.9 for user 3 and 0.7 for user 10. Okay, 0.9 for user 3 and 0.7 for user 10. So what I'll do? So in addition to this weight value, okay, weight value, you have to multiply the rating value. So in order to find the rating, I can say 4 is multiplied by this 0.9 plus 5 is multiplied with the 0.7 divided by sum of these two weight, that is 0.9 plus 0.7. Okay, so if you calculate this one, for example, if I multiply 4 into 0.9, so I'll get 3.6. Similarly, if I go for 5 into 0.7, so I'm getting 3.5. Divided by 0.9 plus 0.7 is 1.6. So if you calculate 3.5 plus 3.6, okay, 3.5 plus 3.6, it is 7.1 divided by 1.6. So if you do so, you will get the value as you will get the value is 3.5 plus 3.6, it is 7.1 divided by 1.6. Yeah, you will get the value as 4.4375. So if I take 2 decimal place, it is 4.44, or 2 single decimal, it is 4.4. So in this way, the weighted average works. For example, if I say, let's say another item, let's say one particular item is purchased, like if I go for I5. I5 is, let's say, purchased by these 3. So I am, let's say, considering these 3 are the neighbors. What I'll do, I'll write 2 is the rating multiplied by 0.9 plus 1 into 0.9 plus 4 into 0.7 divided by, I'll sum all these values, that is 0.9 plus 0.9 plus 0.7. Okay, these are the ratings, right? And these are the weight values. And we add all the weight values and put in the denominator. So if you calculate this one, that is 2 into 0.9 plus 1 into 0.9 plus 4 into 0.7. So you will get the value is 5.5. Divide by 0.9, 0.9 is 1.8. Okay, if you sum 0.9 plus 0.9, you will get 1.8 plus we have 0.7. So you will get 2.5. So 5.5, okay, divided by 2.5. So you will get the value is 2.2. So you will see these values different from the normal average, right? Normal average, if you calculate, it is 2 plus 2 plus 1 plus, 2 plus 1 plus 1 plus 4 divided by 3. How much you will get? If you go for 2 plus 1 plus 2 plus 1 is 3 plus 4, 7 divided by 3. So 7 divided by 3, you will get the value is 2.33. Okay, so you can see the weighted average and this average is different, right? Because we are putting different weight value. Similarly, you can go for difference from mean also. So in difference for mean, what you will do? So for example, you are taking the neighbor of U1 and you found the neighbor of U1 is U3, U7 and U10, right? So you will take the average value of U1, that is 3.50 plus, you can see 0.9. 0.9 is nothing but the weight value which we have considered earlier, and the difference between this current rating and the average rating. Average rating is 3.60. So I am calculating 4 minus 3.60. I am taking this rating 3.50 plus weight value is 0.9 and difference between these two rating, that is 4 minus 3.6 plus, if you go for this particular rating, so weighted 0.7 is nothing but a weight and difference between the rating is 5 minus 3.86. 5 is the rating given and 3.86 is the average rating of the user, divided by what we will do, 0.9 plus 0.7, that is 1.6. So if you calculate this one, for example, let me calculate, simplify this. 4 minus 3.6. Okay, 4 minus 3.6. How much you will get? You will get 0.4 multiplied by 0.9. So it is 0.76 plus 5 minus 3.86. It is 1.14 multiplied by 0.7. So it is 0.798 divided by 1.6 and we have to add 3.5. So 0.76 plus 0.798. So it is 1.558 divided by 1.6 and you have to add 3.5. So 1.588 divided by 1.6, that is nothing but 3.5 plus 0.97375. Okay, so if you sum these two value, how much you will get? You will get the value is 4.47375. Okay. Okay, somehow it will get a close value to 4.36. Okay. If you do so, you will get it, right? So once you determine this value, difference from mean, okay, then that can be considered as one of the measure, right? Similarly, for another one, you also calculate, you can calculate for I5, you can calculate for I3, I2 and I1 and find what is the value if by calculating the difference from mean. Difference of mean says that what is the average rating of a particular user and what is your current rating. What is the difference between these two? That only we are considering and multiplying with the weight value which we have learned in weighted average. So in this way, we are going to calculate the difference from mean. So as a conclusion, I can tell you that recommendation system is a very powerful tool. So it is widely used in the various e-commerce sites as well as social networking website, or any, you can say, business industry. All the business industries relies on the recommendation system. So we have a lot of information, as I mentioned earlier also, but finding an appropriate information that is make more useful, right? So internet is the major source. You can collect the information from various sources, and based upon that you can make a solution. And future research will concentrate on advancing the existing methods and algorithms to improve the quality of recommendation system prediction and recommendation. Day by day, the different models we are using, different aggregate functions we are using, different similarity functions we are using. So these functions will help you to improve our performance. So we are doing improvement of the performance not only by developing the model, but also how to find an appropriate user. What are the measures we need to find to that? So that also we are need to focus. How we are aggregating it, that also we need to focus, right? Based upon that, if you design a new recommendation system and you can show that it is better than the existing recommendation system, definitely that will help everyone to use the recommendation system in a better way. And you can predict some of the items which are interest for a particular user, and we can make a recommendation system work in every field, right? So there is no need of any human intervention, right? The system will automatically learn from the past experience and can suggest the item to the user, right? And if you want to study more, there is a very nice paper by Professor Antonio Hernando from University of Madrid. So in fact, these slides are also taken from Professor Antonio Hernando. He offered a course, GAM course at NIT Roorkela. So I took the slides from his presentation, and some of the slides prepared by me, but most of the slides are given is whatever he has given. The same slides I kept here for easy understanding. And also, if you want to start your work, there is a very good survey paper on recommendation system that is also by the group of Professor Hernando. So that is published in the Knowledge Base System in the year of 2013. That is a very good journal, high impact factor journal. So you can go through this paper, which will give you a clear idea about the recommendation system. Yeah, thank you everyone. So if you have any